everyone. Last year, the code crew attended the Kubernetes days in Zurich, where we learned a lot about eBPF. Sometimes we say it was the eBPF conference, but hey, it's cool. Now today we have Thomas Graf, CTO from Isovalent, now a Cisco company, right? Here telling us the story about Cilium, eBPF, and so on. Thank you for joining us.
Roger. Hoi zusammen, welcome. My name is Thomas. I'm co-founder of Isovalent, now most recently leading the cloud-native networking team at Cisco. Before that, I was at Red Hat for 10 years doing kernel development, so I progressed from hacking the Linux kernel, creating a company, and now finding my way as part of Cisco. Today, I want to talk a little bit about eBPF, Cilium, Tetragon, but also coupled with that, talk about how we built the company and give you a bit of a kind of glimpse into how we started in Switzerland, how we expanded to the world, and how we came back to Switzerland. So about Isovalent, we were a typical Silicon Valley startup. We started in 2016 with venture capital, raised funds from a very famous venture capitalist firm, built a company, progressed to build amazing technology, and now early this year got acquired by Cisco, and now scale our product to the wider market. But today, what I want to focus on is the open source piece of it, because our company has been built entirely on open source software with an open core model, which means that part of our enterprise product is not open source, but that covers about 2 to 5% of the overall product service. So overall, I would still declare ourselves like an open source company because the vast majority of the technology we've built is, of course, open source software. What we have been focusing on is solving problems for platform engineering teams. And I know many of you are either working in a platform engineering team or are using technology or services from a platform engineering team. So whether you're using Kubernetes directly or you're running applications on Kubernetes, or you are maybe thinking about moving towards Kubernetes, these are all topics that the platform engineering team is concerned about. What we're most famous for is a project called Cilium. And Cilium is today a family and an umbrella of different projects. It started out as what's called a CNI, a container networking interface, which essentially is Kubernetes' way of saying what you need for a Kubernetes cluster to have networking. So for what a Kubernetes cluster needs, that workloads running in Kubernetes to even be able to talk to each other across multiple nodes. And this includes a whole bunch of things, not just pure baseline connectivity, it also contains firewall services, load balancing, and so on and so forth. But today, Cilium is much more than just the CNI portion of it. It is multi-cluster, service mesh, network observability, multi-cloud networking, all the way into runtime security with Tetragon. And we'll take a glimpse into what all of that is, and even more importantly, how it works, because I know many of you are interested in the technical bits below it. Cilium has made a pretty big splash in the cloud-native space, and we're now deployed across lots and lots of different verticals with many different customers. You will recognize some of the logos, many of them also here in Switzerland, because we have a very large footprint in Switzerland here, both from an engineering perspective, but also from an overall operations perspective. So about 25% of our 180 people are here in Switzerland, overall about 60 in Europe, and that's 60% in Europe, and that's of course attractive to companies and customers in Europe. But how did it start? Like, where did Cilium get started? All the way back in 2016. This was the original Cilium Design Summit in the Swiss Alps. So it was just the four of us. You see 3 people on the picture because I took the picture, so I'm not in here. So we had a design summit, and as part of this, there's one of our coworkers was from India, never saw snow. So obviously, as Swiss people, we wanted to show snow. So we went to the Swiss Alps. Visibility was 0. So there was absolutely nothing to see. We were the only ones up there. And I think that kind of the survival instincts of our coworker kicked in a little bit. Like, how will I survive this snow, blizzard, 0 visibility? What we took away from this design summit is that connectivity is not enough. Observability is really important. If you don't know where you're going, you're really struggling. That was us back in 2016. This is a look into 2023. Last year, Isovalent team what we have been doing, like spread around the world. We not only invent amazing technology, we also try and have fun while doing so. A lot of activities, and you see actual offsite pictures that we did last October in Maloja in the Swiss Alps again. So we started in Switzerland, and we have been connected, and we'll see some pictures along the slide deck here. Always been connected with Switzerland, and we also came back last year with a company-wide offsite in the Alps. We heard the term eBPF a little bit before. How many of you have heard the term eBPF before? Wow, that's a lot. How many of you have seen the eBPF documentary that came out last year? All right, a couple. So if you want to dive more in this, I will do a very brief intro into eBPF, but if you're interested and you want to learn more, we have actually done an eBPF documentary in the same style as the Kubernetes, Prometheus, and Envoy documentary that gives you all the historic, like how we came along, the challenges, like who was behind it, the whole development story. And it gives a lot of insights into things that you would typically not discover aside from the technical details. But what is this eBPF, right? Typically, like the scientific answer is that eBPF is a virtual machine in the Linux kernel. Now, what does that even mean? It means it's something a little bit like JavaScript, which means you can run a bunch of code in a safe and efficient manner as part of the Linux kernel. So think about it like code that you can run, but instead of as part of the browser, you can run it in your operating system when particular things happen. Many of you probably have used in the past Linux kernel modules, either for drivers or for other modular code where you want to load code or a module into a Linux kernel to like dynamically extend the functionality of the kernel because you need a new driver for a USB device, for example. The problem with that approach is if there is any bug in the code, it literally crashes your kernel. So it's a very unsafe way of extending the Linux kernel. It's also not very portable. You typically need to take a Linux kernel module and actually compile that for the specific version of the Linux kernel version that you are running, because it is using internal APIs that are bound to the version, and every change in the kernel version change the API, and hence you essentially need to have a kernel module compiled for the Linux kernel version you're running. eBPF resolves all of these concerns. It's efficient. It has a just-in-time compiler, so it can just-in-time your generic bytecode and make it as efficient as if you would recompile your kernel. Think like Java that has a just-in-time compiler as well. It is safe. It has a verifier, very similar to how JavaScript is sandboxed in a browser. And it is portable. An eBPF program cannot call into arbitrary kernel APIs, only the stable subset, which makes it portable. So it's a modern new way of extending the Linux kernel in a safe, secure manner. This is an example how it looks like, and to a kernel developer, this is a high-level language, pseudo C code, an example of how system call observability can be gained. So you may have been using a tool such as strace, where you can trace system calls and identify what is my application doing, what sort of system calls are they doing. eBPF can do that as well, but at 100 times more visibility and with more intelligence. We see everything and we can apply logic at the same time. And more importantly, we can block, we can create verdicts, so we can also filter. For example, if you're using Chrome and you're using Chrome plugins, eBPF is used to filter and limit what sort of system calls a Chrome plugin can do. So eBPF is a low-level technology, for example, used to limit the sandbox of a Chrome plugin. Or if you're using an Android device, eBPF is used to do all the traffic accounting for apps. So if you ever looked at how much network traffic is a particular app producing or consuming, eBPF was used to do all of that. So eBPF, incredibly powerful, hooked into the kernel, and we can write code, high-level code, and essentially run that, for example, when a system call is being performed, when a network packet is being processed, and so on. So think it a bit like very similar to what we can do with JavaScript. When we click on a button, we can run a bunch of code. We can do something very similar at kernel level when system calls and other events are happening. I know that I'm super excited about this because this is incredibly powerful, but this is not this is not an end-user facing technology at all. Like, this is aimed and tailored at kernel developers, right? You're not going to rewrite your business application to use eBPF. What this is tailored for is writing like next generation, top modern infrastructure software, like security solutions, firewalls, networking software, and so on. So for us infrastructure nerds, we're super excited about this. We've used eBPF to build an entire ecosystem of tooling. So you see a full stack of what we can do with eBPF as part of Cilium and Tetragon. This spans the CNI layer, where we can have like a connectivity layer or a networking layer. We can provide IPv4, IPv6 connectivity, service load balancing, transparent encryption with IPsec and WireGuard, network policy, segmentation, and a whole bunch of advanced network complexity or advanced network functionality, such as egress gateway, running BGP networks, and so on. So a very modern container-oriented networking solution. On top of that, and we'll look at a couple of examples, we have an entire observability platform that can give you flow logs, metrics, Grafana dashboards, logs into Splunk, Elastic, and so on. And then on a very high level top, the service mesh, which brings all of this at layer 7. So load balancing, policy, resilience, but with understanding of protocols like HTTP and gRPC and other layer 7 protocols, not just the pure layer 7 or the pure layer 4 networking layer. And on the right side, Tetragon, a runtime security solution. All of this essentially combined, built out of eBPF, is the Cilium and Tetragon solution, and essentially what we offer as a company. So let's dive in a bit. How did it get to this full solution, and how did the team, like what did we as a team, did we survive, or what did we live through as we went through this? The initial phase that we built, or what we built first, was a basic CNI, a Kubernetes networking solution with firewalling capabilities. So connecting pods, connecting containers, and allowing to define rules, who is allowed to talk to what other pod. And we did so using eBPF, which has great performance and security benefits. And we actually presented this back in 2017 at DockerCon, which literally changed almost everything for Cilium, because we went from being a small little GitHub project with like 200 stars to something with over 1,000 stars and a lot of people talking about it. Coincidentally, this was also the DockerCon when Kubernetes really sparked off. Some of you may remember Docker was very dominant in the market, right? And then Kubernetes came around and changed everything. This all happened at DockerCon, which I think must have probably stung a little bit for the Docker folks, that Kubernetes essentially sparked at DockerCon back in 2017. That was also the sparking moment for us. If you have seen this talk, it was super fascinating, because the Star Wars demo that we did was like the clear highlight. We got into a little bit of legal trouble back then because my co-founder played the Star Wars music while I was presenting on screen, and that was obviously a bit of a copyright violation and caused some problem with the video recording that had to be sorted out afterwards. But still, the YouTube recording became pretty popular afterwards. We also got our first office in Switzerland. This is our Volkertswil office. It's a region outside of Zurich, pretty cheap. So we had this like tiny little small office. One of our kernel engineers ironing this is a booth back wall. So we had a conference booth at KubeCon, and because we didn't have office decoration yet, we literally took the back wall with us so we could hang it in our office. And obviously, because we're expecting customers, we had to iron it, because of course wrinkles wouldn't look great for customers. We also designed the Cilium logo, so that's the original drawing of the Cilium logo when we designed it, and of course we celebrated birthdays as well. We then also started to grow in 2018. So this is our KubeCon presence in 2018. This was already massively big for us. So not having this tiny little one-person kiosk stand, but actually having a booth with a back wall. And we reached 2,000 GitHub stars, which was unbelievable for us back then. We also did early team building exercise. So this was an early team offsite. A bunch of engineers decided, let's go skiing early on. Let's actually go to the skiing resort in the morning, use every possible hour. And on the Julia Pass day, were forced to mount snow chains. Typical engineering division of concern. One person trying to figure it out without the manual. Another person just looking at it, one person looking for a YouTube video how to mount snow chains. and the product manager taking the picture, right? So like a typical division of labor here. We always also brought like Swiss culture. This is in Palo Alto. In Silicon Valley, we had an Airbnb rented, and we did a Swiss fondue, like a typical Swiss meal where we did some team bonding. And then, of course, a lot of skiing all the time. We had a lot of, I think, people that are either into skiing or were successful in making others, I would say, excited about learning about this activity overall. And the last picture is overseeing Zurich. That's on Uttokulm, Uetliberg, the small little hill. Let's not call it a mountain, a small little hill overseeing Zurich. We expanded from a technology perspective as well. So instead of just doing low-level bits and moving network packets around, we started building a UI. We see two aspects here. Hubble UI, which is essentially giving you a service map, who is talking to whom, what namespaces are running, this app is talking to this app, what protocols are you using, and so on, as well as a policy manager. Like if you have been using Kubernetes, it's all about YAML, right? And in the first couple of weeks, that's pretty exciting. And at some point, you start getting bored, like hunting for typos and spaces that should be tabs and all sorts of things. So we build a UI that essentially allows you to build network policy firewall rules in the UI and also to validate them instead of writing YAML. So you can see the UI portion on top and then the YAML down here. So you can click through and get the YAML and impress your coworkers with this massive sheet of YAML that you just typed, right? And of course, to keep the security side of the company happy, SIM or SIM integration is important. So feeding flow logs, observability logs into an SIM like Splunk or Elastic, or of course, a cloud provider managed resource as well. In 2021, things started to get a little bit crazy for us because Google announced that they will, or Google approached us and said, hey, we would like to actually use Cilium. We heard about eBPF, this is great. We don't want to start from scratch. Can we strike a deal? You help us out a little bit and we will use Cilium as part of the Google Kubernetes engine or GKE. It was just massive for us. We were like 17 people companies, like big Google coming to us and saying, hey, we want to use you, all of this. And we tried to like stay cool and not show our excitement too much, right? And essentially, we struck a deal which also included Google Cloud investing in our company, and as a result, we helped Google essentially bring Cilium to the market in GKE, and as a result of that, of course, Cilium gained more popularity. And as usual with cloud providers, if one of them is starting to do something, all of them wanted to follow, right? Because they all like, oh, Google has something, we also need this as well. So of course, just a couple of months later, AWS came to our door and, hey, we heard about Cilium, we also need this apparently, can you help us? And then a year later, Microsoft came around and now Cilium is powering essentially GKE, parts of EKS Anywhere, and also AKS, where it's called Azure CNI, powered by Cilium. So if you're using managed Kubernetes platforms today in the cloud, you're most likely already using Cilium, or you have the option to simply upgrade to Cilium for your cloud-native networking operations. We also joined the CNCF, so we were always an open source project and always openly governed, but we specifically decided against joining the CNCF as a small project. We wanted to first become successful on our own and then think about governance and potentially dedicate the project to a particular kind of foundation umbrella, because foundations also have a lifespan, as those of us know who have been around during the OpenStack days. Not everything is forever, so an open source project should also, I think, decide wisely to what life cycle to actually attach themselves to. But in 2021, we said CNCF is what makes sense for us, and we started as an incubating project, and then a couple of years later, we graduated and are now one of the graduated CNCF projects. As I mentioned, we learned in that early design summit that observability is really important. We had a lot of observability from early on, but in essentially 2022 is when we started to really invest more into the observability side and not just provide the data, but to also actually make that available to end users. And we massively expanded our visualization engine. So ability to essentially visualize microservices, either on just service-to-service level, but even on the tracing level as well. So being able to see every function call of your applications, whether this is a gRPC call, an HTTP REST API call, or it's a database lookup. Like you can see a select call on a particular database or an update call, and so on. The business kept growing, and we raised a Series B. So that's like in VC terms, like startups raise like different fundraising rounds, like seed round, then an A round, a B round, a C round, and eventually all the way to IPO. This was our B round from Tom West Venture, because at this point the business side, the commercial side of our company started to really grow, fueled by all of the open source excitement that we had created. Now, as the Kubernetes market started to grow, the business side grew as well. And you can see Cisco was already kind of looking around and became one of the investors in us as well, to essentially get what's called board observer rights, where they can observe a bit closer what the company is actually doing. We also struck a deal with Grafana Labs, the company behind the Grafana open source technology, and we essentially said, well, we're kernel engineers, we're great at low-level bits, we really suck at UI. Can you help us out with the fancy dashboards? In return, we can give you a lot of exciting, very detailed, very accurate observability data. And together, I think we had a classical win-win situation where we gained a bunch of out of the dashboards, like the one we're seeing here, where end users can now observe the networks, policy operations, building golden signal dashboards, all you want, visualize that in exciting Grafana dashboards. And Grafana, on the other hand, got a data source with eBPF that is lower overhead and has a lot more context than a typical solution that is not leveraging eBPF. So it was a typical win-win situation. This is one of the most, let's say, successful or most prominent use of it. How many of you are using something called Golden Signal Dashboard, like a concept that Google has introduced in their SRE handbook? Not many yet, so definitely an opportunity. So if you want, it's actually it's a very exciting concept. It's a concept that is trying to essentially help you with the finger pointing problem, that if your application is not working correctly, you want to understand, is it infrastructure, is it the user, or is it the app? And to answer this question, you need to correlate data, because typically if you jump straight into application logs, doesn't help. If you jump straight into calling the end user, what did you do? Doesn't help, doesn't scale. If you only if you have a fully distributed application, if you just look into one node and see if the application is running correctly there, also doesn't scale. So you need some form of correlation to actually get a sense into what direction you want to look into. So a golden signal dashboard gives you, I'd say, 4 major sources. You see the number of user requests coming in. So think about this as the number of websites hits that your application is getting, or the number of users that are currently accessing your platform. Then you also see the number of unsuccessful requests. So this is literally how many times your website or app actually returns an HTTP 500. So if this spikes, you see that users are getting like results that are not great. And then you also see the latency all the way on the right. So you can see if there's a latency spike, are my end users receiving a worse performance than before? And you see this over time. So you see if something changed. And then you see the CPU correlation, because if it is slow, then you immediately want to know, why is it slow? Is it because it's slow because there is not enough CPU? And you also see what's called the throughput, or is it because there is not enough network bandwidth? So this golden signal dashboard is allowing you to quickly correlate over time what is the actual symptom, and then also what is the most likely cause for that symptom. So very interesting content. You can just Google golden signal dashboard and you will find a reference to the Google SRE handbook, where Google is running this at scale to troubleshoot applications. You can get this sort of dashboard, of course, with Cilium and the Grafana dashboard. Of course, we didn't just like to develop technology, we also took care of our loved ones. This is from our Slack channel, all like the pets. As the company grew, we gained a lot of pets in the team. This is one of our most popular Slack channels. But then back to the technology side, we quickly learned that just taking care of a single Kubernetes cluster is not really sufficient for most of our end users. So the concept of a multi-cluster solution was pretty obvious. So this means that instead of just providing connectivity in one particular cluster and seeing it as a silo, as an island, instead what customers and users wanted is a networking plane that allows to connect multiple clusters together, either all running in the same cloud provider or also hybrid cloud use cases where you have a classic Kubernetes cluster in public cloud, for example, AKS, and you're also running an OpenShift cluster on-prem. How do I connect these workloads together? How do I secure this? How do I encrypt traffic? And so on. So multi-cluster. Cilium offers here essentially a plane that connects all of the clusters together without requiring any sort of federation in the Kubernetes cluster. So the clusters will continue to operate on its own. So the failure domain, the availability zone, stays intact as is, but the network data plane can expand, and you can now expose services. So you can expose one workload as a service to another cluster and make that available. And all of that using standard Kubernetes services. So for those of you who are using Kubernetes, you can annotate a service as global, and the global service will be made available to other clusters. Pretty straightforward and simple without requiring new forms of service discovery or anything like that. But again, team building was never, was always important. So this is us trying to curl. When we did this, I was at first a little bit like, why are they giving us helmets? So that you see in the picture, we're all wearing helmets, right? And I was like, do we really need those helmets? And like, it was only seconds later when I saw the first engineer like doing almost like a flip backwards, and I already saw the brain splashing on the eyes. I was like, yes, good call to give us all helmets. We invested a lot into hiring good talent. It's good to protect those engineering brains. So I was actually very glad. But I just didn't have a mental picture of curling and helmets together. In this next phase, we started to expand outside of Kubernetes. So far, we've looked at Kubernetes and how we enable connectivity and security and encryption in Kubernetes. Users came around and said, that's great. Like, you're really good at what you're doing on the connectivity side. Can you start taking care of the load balancer outside or in front of Kubernetes? Because most customers would have something like an F5 big IP or a Citrix NetScaler, some big hardware firewall box, or very expensive cloud provider load balancers such as an ALB. Can you also provide that? And can we manage that from the Kubernetes side as well? So we built a load balancer, eBPF XDP based, that from a performance perspective can easily compete with an F5 big IP or a Citrix NetScaler that is running in hardware, but entirely in software that can run on any Linux machine that you want. And then we expanded on the visibility side. So once we started doing multi-cluster and the load balancer, customers came back and said, great, you have observability, but now we want to have this full end-to-end observability. We want to see how a packet is flowing through the load balancer into cluster 1 and then into cluster 2 and so on. So we built Timescape to correlate all of the network observability together across multiple observability points to give you that full tracing observability from point to point to point to do troubleshooting, auditing, and so on. And of course, this Timescape, that's a ClickHouse-based time series database. It can still run the Hubble UI, that's the top right, and the Grafana dashboards, that's the bottom right UI on top of that as well. What you've gained is to be able to observe everything across multiple clusters. And this is how it looks like. So Hubble UI, and then also there's a CLI where you can actually, if you have a lot of data, maybe you just want to use the CLI where you can query flows. We have some customers running tens of thousands of nodes. At that point, the UI is not necessarily the right choice anymore, so you'd rather go the CLI route and actually filter on what you want. And of course, engineers need to be motivated, and that's often done with good food. So that's a picture from our office in Zurich with food. And then if food doesn't work, then we use laser tag, which is also very effective in, I think, building fun team experiences. The last expansion we did on the networking side is into multi-cloud. So again, another step moving outside of Kubernetes. Can we bring modern cloud-native networking to VMs and bare metal machines. So apply that not only to containers, but to VMs and servers. So with the multi-cloud and hybrid cloud solution, we can now essentially deploy Cilium as what's called a transit gateway. So think about this as a software router that you can run on any Linux machine, and it can now be the gateway into the more modern cloud-native mesh. So you can have a bunch of physical servers sitting in your own data center, or you can have public cloud provider hosted VMs or an existing VMware data center. You can now integrate them directly into your Kubernetes environment, run network policy, run observability, run transparent encryption, and so on, all with the transit gateway. So that's the piece here on the right. So we can now essentially cover everything from the end user with a smartphone, for example, load balancer, your workloads running in Kubernetes, all the way into your, maybe, for example, database backend that is still running on an Oracle database in your data center. All of it from left to right, you can now cover with a Cilium network data plane. That was the networking piece. How many of you have looked into service mesh? A few hands, yeah? So when I first encountered service mesh, my question was like, why? So as a networking person, like, why? Haven't we been doing this all, like connectivity, resilience, load balancing, like what's new about this? Why do we need something new? And service mesh really comes from a world where application developers were not really happy with the infrastructure that the network team provided. So the resilience was not good enough. Yes, TCP is kind of resilient. It was designed and built to withstand an atomic attack, right? But it was designed in the 80s, so it's a little bit dated. It does not have something such as, for example, retries. As an application developer, what I want is if an application fails, I want the HTTP request that came into the application to be retried to another replica of that same application. That's not something that TCP can offer me. That's why service mesh was essentially invented from application developers trying to provide infrastructure. The benefit here is that what we can provide service mesh entirely without what's called a sidecar proxy. So instead of deploying thousands or 10,000s of so-called sidecar proxies, we can provide this entirely with eBPF native, which gives you performance and latency gains. So we see service mesh as a natural extension of Cilium and networking, that we provide your service mesh capabilities as an integral part of the networking layer. All right, and then as the last piece here, last year we invented something called instant regret hikes. Can some of you kind of guess what that could potentially be? So when you see the picture here in the middle, that was relatively early on in the picture. But if you have people already question their decision, whether it was a good decision to join the hike, or like maybe this was longer than I was thinking about, that's when the term was coined, instant regret. So a hike that you regret some point in. We had a bunch of fun, like for sure, but there's also a lot of potential in the Swiss Alps to go along as well. All right, so that's the material I had so far, and I would want to say thank you very much for coming, and thanks for the interest, and maybe we have a bit of time for questions.
You mentioned that eBPF is mostly for kernel developers, but I have observed in the latest time efforts to have eBPF for unprivileged users.
Yeah.
What sounds a bit scary. How do you see it? How does it fit together?
First of all, it is scary, and you should only enable it. So your standard Linux distribution will not enable it by default. So you will have to enable unprivileged eBPF if you want so. The reason why it exists is because sophisticated application teams at Meta, formerly Facebook, they really wanted to be able for regular unprivileged application teams to be able to use eBPF for application profiling and tracing. So what you're doing, and you know that you're only running these, I would say, safe applications, it's definitely not advisable to run unprivileged eBPF enabled on a random server where you're running critical workloads on. But that's the motivation, right? To run application developer tooling to essentially CPU profile your application in prod, right? So whether that's advisable or not, open question. We can debate, but early inventors or early people involved in eBPF are definitely interested in doing that.
May I have another one? Okay. You mentioned that eBPF is somehow it's more secure way to replace modules.
Yeah.
But modules can be signed and checked by the kernel. But
yeah.
how it looks like with eBPF? So I know that there are some efforts to go in that way and that it's difficult. How does it look like?
Yeah, so first of all, there's two aspects to security. Is the program safe to run? That part eBPF is solving, kernel modules are not solving at all, right? Like the eBPF has a verifier, can I run this safely? And as long as there is no bug in the verifier, it will be able to answer this question. The other question is, am I running the code that I was intending to run? That's where signing is coming in. That's easy for a static kernel module. Very simple, because your vendor, like let's say Red Hat or SUSE or some other provider of Linux distribution, is giving you the modules, they're static, they're not changing, you can sign them, relatively easy problem to solve. For eBPF with dynamic code, harder. Like it's underway, but because it's harder, it is a bit more challenging to solve, but it will definitely come. What's happening right now is that components such as Cilium will essentially validate themselves. So we are, like Cilium itself will make sure that we're only running the programs that we intend to run. So we also bring supply chain security aspect, but it's not done in an overall eBPF signature approach yet. But everybody involved is very interested and motivated to get it done.
I would like to ask how much your company or your project influenced the design of network policies in Kubernetes, and whether, because I understand that your commercial product is much more capable, and if there will be news in there, or you still influence it, or what's the next steps in the network policies?
Yeah, so we have been very involved from the very beginning of the creation of network policy. And others involved were, like, of course, Google as primary inventors of the overall Kubernetes ecosystem. Tigera with Calico was very involved. IBM was very involved. So there were a set of vendors involved in what's called SIG network, which was defining the network policy format. We were also, and of course, we've always implemented it, done it, and have always been participating. At the same time, we've always also been following the principle of the best way of invention and innovation is to try it out and listen to end users, and then iterate with that instead of having debates with other vendors what could make sense, and actually just have more feedback from the direct end users. So we've also always been implementing a custom resource called Cilium Network Policy, which has more capabilities. And then what made sense, we brought back into the network policy standard.
Now that you covered the whole story, what's the next big thing for Isovalent and Cilium?
Yeah, we're super excited that as part of Cisco, we can take the next step that we had already planned. I think we've been pretty popular in the cloud-native space, but the team is very eager to build a networking layer and solution that goes beyond just the cloud-native and Kubernetes space, even though that's already pretty big. We want to become, I think, the next overall NSX-like networking layer for the age of public cloud. So that's clearly the appetite we have as a team. That involves also being usable and prevalent in the data center. That means having a multi-cloud story that's not just Kubernetes. That means having a compelling firewall story. That means having a compelling SD-WAN story. Like, we want to build the Cilium empire in the networking world.
We are often confronted with technologies that have been used in the past, and part of this are physical firewalls. How do physical firewalls compare or relate to Cilium, and what's the answer if we get questions from these people?
Yeah, so I think this is an excellent question. I'd say something that has been in my working environment for the last 25 years. You want the performance of hardware and you want the innovation, lifecycle, and flexibility of software. And software-defined networking, ASICs, programmable hardware has always been trying to find that middle ground. Whether that perfect middle ground really exists, I don't know. What I believe in is that you definitely need a little bit of both. I'm a software person, so I've only ever been writing software. And even though I'm often getting asked by hardware vendors, well, could we work with you to offload Cilium into hardware, this and that, DPUs and all of that? There is space for that, but for the vast majority of use cases, pure software approaches, in particular in public cloud, are more than efficient enough. On the other hand, which you see with the current era of AI, some aspects, hardware can make a massive difference. If you look at GPUs right now, it's changed the game forever, what's possible. Or if you look at Android phones or smartphones, like nobody would ever thought that Intel could get challenged from what's possible with hardware, but they were, and it has unlocked a completely new era of low energy or low power consumption CPU power. So there is, I would say, this 10x, 100x modifier that hardware can do, but it's also incredibly more challenging to do this in hardware in a way that actually meets a current market need, because in hardware innovation cycle is 5 to 10 years. Software we can change in days or hours. That almost creates an unfair balance for the maturity of the market. So that's why we're also excited with the Cisco partnership. We can continue software side, and Cisco has huge ambitions to becoming a software company, while also being able to leverage a lot of knowledge and a lot of current ecosystem around hardware, because that combination is what's needed to actually be, I would say, the really wide solution that everybody needs.
Thanks a lot, Thomas.